Hello, my name is Lori Huseby. I am Group 3, and my final project is about the high school sports management database. So, as an introduction to this database, we have some background. So, this was from an interview from the current volleyball coach at my old high school. And this database would be used for managing rosters and balances for students who have signed up for various sports, whether they be outstanding balances or completed. It shows the hierarchy between administration, parents, students, and coaches. It allows ease of access to fees and students' eligibility and to be able to create reports from that. For the functions that the database supports, the first one is planning and managing sports participation and fees, and the second one is coordinating communication between coaches, students, and parents through various types of communication. One of these communications is between phone numbers, so the phone number of the coaches and the parents is entered into the database, as well as the emails for the coaches, so there is clear communication. There are many types of data that is collected in this database. First, we have the student, parent, and coach information, as well as the age of the coach and the student. We have the student and coach sex in order to group them in the case of like men's and women's hockey. We have the sports starts and end dates, the name and the type of sport, and the type stands for whether it be a contact, half contact, or no contact sport. The price of the sport, as well as the status of participation, whether or not, say, the coach is active right now in the season. There are three main types of reports that are created. The first one are queries, which would be included with the student fee report as well as the coach information report. We can create a list, such as a team roster, athletes who are in more than one sport, as well as possible sport like date conflicts. And the third one is billing, which is the total fees unpaid, and they can be grouped by children, they can be grouped by sport, and they can be grouped by parents, as well as the total student eligibility. These are the business rules for the database. The most important one that I would like to pick out is number 5, where only one set of parents can have one-to-many students, and one-to-many students can have only one set of parents. This was simply for ease of access, as it was much harder to put in 2 sets of locations for parents rather than one. If this database were to be improved, that would be a big improvement, and that should be added. Here is the conceptual data model for the database. The first thing that we had was a many-to-many relationship between sport and student, and so inserting that in role allowed us to have a bridge entity. We added a list attribute in order to organize acronyms such as state names and the half contact, contact, and no contact acronyms. And then, yet again, due to simplicity, the parent attribute assumes that both parents live together, and there is currently no spot for 2 different parent locations. The second model that we made was the logical data model. And so in this model, the arrow between the attribute goes from the foreign key towards the primary key, and then associates that the mini side of the ERD that we just saw is the side of the arrow without the arrow. Then we created the SQL reset script, and the reset script is used to reset the tables of the database. The tables must be in order so that they do not interfere with each other. An example of that is just foreign key and primary key, like a mix-up. And then being able to drop these tables effectively allows us to, quote, restart the database if there is an error and just kind of try those statements again. Next, we created tables for our SQL script. So this is just 3 screenshots of 3 tables that were created. So we have the parent table, the enroll table, which was the bridge entity, so there are more foreign keys, and then created the list table as well, just to associate with those acronyms. Next, we created the insert statements. So 5 records were inserted into each attribute to be able to fully use the database. Obviously, if this were to be used in a more real setting, there would be more records. But the screenshots that we have here are the sport records that we found, as well as list records that we have, just explaining the acronyms once again. This is one of the first SQL select query and sample outputs that we had. And so this select statement displays the coaches that are coaching sports that are currently active, as well as labeling the sport that they coach. And so we selected the coach ID, first and last name, email, as well as the sport name. And so this only included the coaches where the sport status equals A for active. And so we see that in the output, we see that only the sports of hockey and basketball are currently playing, and that gives us the email and the names of them. The second SQL select query that we are displaying uses an aggregate function. So this statement displays the parent's phone and the total balance. So we summed all of the student balance for each parent as total balance, and we see where the parent ID equals the student parent ID, and so we grouped them by the parent ID as well as the phone. And then we see that the total balance is summed for each of the students that are in our database. This is a SQL select statement with multiple inner joins. And so what this select statement did was selected the entire hockey roster. And this can be replaced by other sports. All it has to change is the sport name. And so here we have 2 inner joins from the student to enroll, and then joining both of those with the sport. And so in the output, we see that there are currently 2 people playing hockey, and both of them are females. And if there were to be more people, we could subdivide them further based on male and female as well if we wanted to. These are the references that I used. I used 3 different references. One was the book, 2 was the design process of a sport-related database, as well as SQL subqueries. Thank you so much for listening to this presentation.